Dear students, in the previous modules, we have discussed several problem solving techniques like algorithms, flowchart and pseudocode. In this module, we will discuss about programming paradigms. We can define programming paradigm as a way to classify programming languages based on their features. We will see that programming languages can be classified into different paradigms. Common programming paradigms include imperative and declarative paradigms. Under the imperative paradigm, the programmer instructs the machine how to change its state. The state of a program is collectively described by its variables. There are two subtypes within the paradigm, namely the procedural and the object oriented. Procedural, wherein instructions are grouped into procedures. Procedures are known as routines, subroutines or functions, simply contain a series of computational steps to be carried out. Any given procedure might be called at any point during the program's execution, including by other program or itself. Major procedural programming languages which first appeared in 1960 include Fortran, Algol, COBOL and BASIC. Later, Pascal and C were published closer to the 1970s. In object oriented paradigm, instructions are grouped together with a part of the state they operate on. We call such entities objects. An object might contain data in the form of fields, also known as attributes. The part of an object is code in the form of procedure, popularly known as methods. Under the paradigm known as declarative paradigm, the programmer merely declares properties of the desired result, but not how to compute it. Examples of declarative paradigm are functional, logic and mathematical. Functional, in which the desired result is declared as the value of a series of function applications. In logic, in which the desired result is declared as the answer to a questions about a system of facts and rules. Mathematical, in which the desired result is declared as a solution of an optimization problem. Henceforward, we will keep aside the declarative paradigm and concentrate on the imperative and its subtypes. Structured programming is a programming paradigm derived from the procedural approach. It is aimed at improving the clarity, quality and the development time of a computer program by making extensive use of structured control constructs. There are three major control flow constructs: selection, which consists of if, then, else, and repetition, which consists of while and for, and block structures and subroutines. Structured programming emerged in the late 1950s with the appearance of the Algol 58 and Algol 60 programming languages. Algol 60 included support for block structures. Two factors have contributed to the popularity and widespread acceptance of structured programming in both academia and later among practitioners. One of the structured programming theorem, also known as Bohm-Jacopini theorem, it states that any computable function can be computed, of course by a computer, by a class of control flow graphs if it combines subfunctions in only three specific ways: sequence, that is executing one subprogram and then another subprogram; selection, that is executing one of the two subprograms according to the value of a Boolean expression; iteration, that is repetitively executing a subprogram as long as a Boolean expression is true. And the other factors was due to Edsger Dijkstra, who wrote the influential open letter in 1968 entitled "Go-to Statement Considered Harmful." It was Dijkstra's who also coined the term structured programming. By the way, why is go-to considered a taboo or forbidden in structured programming? What is your response? Go-to is a statement that has the power to transfer the program control arbitrarily to any location identified by a label in the program. Generally, go-to is used in conjunction with an if condition like if condition then go to a label. If go-to statement is used liberally, programmers tend to write code that becomes cluttered, difficult to understand and maintain. Moreover, the structured programming theorem discussed previously proves that the go-to statement is not necessary to write programs. Hence, it is recommended that go-to should be avoided in structured programming. It should be used sparingly where there are no other choices left. One legitimate use of go-to can be in the case when we want to exit a loop or a nested loops under some condition. However, modern programming languages like C have variant of go-to statements like break and continue. These are not as powerful as go-to, but can alter program control to some limited scope. We will see a great deal of this as we move forward. Now, it is time to investigate deeper into the concept of structured programming. We will discuss about the elements of structured programming first. Have a look at the figure. You can see that the graphical representation of the three basic patterns, namely the sequence, selection and repetition. They are called control structures. You can also observe that each basic pattern is depicted using NS diagram shown in blue and flowcharts shown in green. The one on your left is the sequence, an ordered set of statements of subroutines executed in sequence, that is one after the other. In the middle, you can find the selection. One or more number of statements is executed depending on the state of a program, that is condition. This is usually expressed with keywords such as if, then, else, end if in most of the programming languages. And finally, on the right, you can see the iteration. A statement or block is executed until the program reaches a certain condition or state, or operations have been applied to every element of a collection. This is usually expressed with keywords such as while, repeat, for or do until. It is recommended that each loop should have only one entry point. You may have multiple exit points from a loop in modern programming languages. However, in the original structured programming, there should be only one exit point, and a few languages enforce on this. Apart from the above, we have some more control structures which play a central role in the field of computer science. It is the recursion. Recursion is a statement is executed by repeatedly calling itself until termination conditions are met. While recursion is similar in practice to iteration loops, recursion loops may be more computationally efficient and elegant to express and are implemented differently as cascading stack. A subroutine is a sequence of program instructions that perform a specific task packaged as a unit. This unit can then be used in programs whenever the particular task should be performed. Subroutines are callable units such as procedures, functions, methods or subprograms which are used to allow a sequence referred to by a single statement. The name subprogram suggests a subroutine that behaves in much the same way as a computer program that is used in one step in a larger program or another subprogram. A subroutine is often coded so that it can be started several times and from several places during one execution of the program, including from other subroutines, and then branch back, that is return to the next instruction after the call once the subroutine task is done. Subprograms may be defined within programs or separately in libraries that can be used by many programs. In different programming languages, a subroutine may be called by different name, which include a procedure, a function, a routine, a method, or a subprogram. Subroutines are powerful programming tool, and the syntax of many programming languages includes support for writing and using them. Judicious use of subroutines will often substantially reduce the cost of developing and maintaining a large program while increasing its quality and reliability. For example, through the structured programming approach, subroutines often compiled into libraries, which an important mechanism for sharing and trading software. When we get deeper into Python, we see that the discipline of object-oriented programming is based on objects and methods. The methods are basically subroutines attached to these objects or object classes. A block or code block is a lexical structure of source code which is grouped together. Block may consist of one or more declaration and statements. A programming language that permits the creation of blocks, including blocks nested within other blocks, is called a block structured programming language. Blocks are fundamental to structured programming, where control structures are formed from blocks. The function of block in programming is to enable groups of statements to be treated as if they were one statement and to narrow the lexical scope of objects such as variables. Procedures and functions declared in a block so that they do not conflict with those having the same name used elsewhere. In a block structured programming language, the object named in outer block are visible inside inner blocks unless they are masked by objects declared within the same name. Block structured languages have a syntax for enclosing structures in a formal way. A few of them are illustrated in the figure. Have a look at it. An if statement bracketed by if with some statements and ends with fi as in Algol 68, and in other languages if followed by set of statements and end if as shown in the figure. In some languages like Python, white space indentations are used to create blocks such as shown in the figure. A code section bracketed by begin and end keywords as done in PL1 and Pascal programming. The curly braces of C and many other languages. In this figure, you see the three basic control structures stated in the theorem. The first on the left, on your left, you can see a block of code consisting of three statements, and in the middle you can see the second structure, that is the selection. On the right you can see the third structure, that is called the iteration or the looping structure. Coming to the first one, the sequence. Here we can find that there are a sequence consists of a single statement or maybe multiple statements arranged in order, where the sequences are executed one after the other. This is shown in two notations. The blue notation is the formal NS notation, while the green one is the flowchart notation. In the middle, you can find the selection construct. In the selection construct, you see there is a condition, and this condition, based on the outcome of this condition, two different statements or group of statements are executed. If the condition is true, then this statement under the label y is executed, and if the condition is false, then the statements under the label n is executed. So, this is called the selection, selecting more than one path based on condition. This structure is actually available in various programming languages in the form of a if, then, else statement, or in some languages the same thing can be used in a nested manner. We call it a if else ladder, or in languages like C language we have a special construct called the switch statement, wherein we can select any one path out of n number of paths that are available. Coming to the third one, the looping construct or the iteration construct. In this iteration construct, we find that there is a condition. Based on the outcome of that condition, that is, if the condition is true, a set of statements is executed some n number of times. So, this is called a looping structure, where a statement or a group of statements can be repeated for a set of period. The amount of time or the number of time we have to repeat the statements depends upon the condition. Sometimes we may know the exact number of times we may want to repeat the statement. Say for example, you want to repeat it say 100 times or say 200 times. So, in that case we designate that in most programming languages using a for construct, where we say for some variable. In some languages it is represented by a for construct, where the statement following a for or in a block of for are repeated for a predefined number of times, where the programmer can also select the step size also. Sometimes we may not know how many times to repeat a statement. Say in case of you are reading a file, in that case we may not know the size of the file or the number of lines in the file. In that case we do not know how many times we have to repeat. So, we can put a condition here with the keyword while. So, while some condition, for example, end of file is met, or while the user strikes some key, until that time you keep on repeating the statement. Here the set of statements will be repeated until that particular event occurs. So, nevertheless, whatever be the condition, the essence of this iteration is that a set of statements is repeated again and again for a specific number of times. So, this is all about the three basic constructs that are available, that is the sequence and the selection and the looping structure. So, apart from this, we have one more construct that is very much a central role, plays a central role in our computer science, and that is a recursion. So, recursion is a procedure or function which is called again and again by within itself. So, it is a form of looping, but it does not use the structure of a loop, but whereas it uses a nested call of a function within itself. So, such a construct is very much useful in very elegantly we can describe some constructs of a program with the recursion. The program becomes very legible and becomes easy to understand. is an example of the selection. So, here we use the, you can see that in we have an if statement followed by a condition, and that the condition returns a Boolean value, that is whether it is true or false. If it is true, then the block under the then part is executed, the then part is executed until the condition is, if the condition is true. We have given the example of a nested if loop, a selection statement which is nested within itself. So, we have an outer if here and we have an inner if. Okay. So, there are two nested blocks, example of two nested blocks, and if is actually an if block is terminated by an corresponding end if statement. Certain programming languages like Python, for example. So, we will be studying Python in our course. So, we find that we do not use any specific characters for marking a block. So, here what we do is we use indentation as a marker for a block. For example, the block 1 actually is indent at a particular level, say here, and a block 2 which is nested within block 1 is actually indented even further than block 1. Then we have one more indentation level from block 3 which is say nested between block 1 and block 2. Okay. So, this is an example of indentation, that a white space indentation is used to mark blocks in a programming languages like Python. In older programming languages like PL1 and Pascal, we have specific statements like a keyword like begin and end. Begin marks the beginning of a block and end marks the ending of a block. So, within begin and end we can have several statements. We can have several other blocks nested within begin and end, and the level can go on to any particular level. So, this keeps on repeating, and this is called, this is way how a block structured language like Pascal is declared. In the languages like C, as most of us are familiar, we use a curly brace to mark a block. So, here in this particular example you can find that we have the main function which is started with a curly brace, open brace, and then we have a set of statements like a declaration, then read statements, then some instructions like summing up the statements and printing the result, and finally returning the value. So, all these statements are nested within this two curly braces that marks the block. So, in this case we see that the main function is a single block of code in C language. In C language, the blocks are marked by these curly braces, which are of course to arbitrary number of levels we can keep on nesting them. So, in short we can say that the in block structure languages there is a hierarchy, we follow a hierarchy of blocks. So, from starting from the program which is the highest hierarchy, which is itself a block. So, within a block we can have nested blocks like modules and functions. Each function is also a block. Within a module or a function we have other blocks like your repetitions, selections and your sequence, and within a block we have statements. A statement may contain a block of a group of statements or a single statement. A single statement may contain expression, and expression contains variables and operators. So, to this fine level, so we have a hierarchy starting from the higher level of a program, finally to the last level of literal variables and operators. So, this is how a block structured languages are organized.